Great. Huh. Huh. Now I'll start to jara check that. I have told this fellow also to check code. Uh, Shweta, sorry, Shweta, we are trying some new technology. Why we are doing this? Now we are also learning how to do streaming with the help of what you call some new software which has come. So while I am teaching you, we are testing something else also. So I am learning that. Okay, chalo. So what happens is, now when we are talking about this chapter, the heading is that we are just some basic concepts of chemistry. Earlier we used to call this as mole concept, but nowadays we call this relevant because some basic concept of chemistry. Okay. So I will be continuing this Sunday. Okay. All Sundays now we'll finish this chapter because I've done for those fellows because they are taking the examination. So now in some basic concepts of it, I read the first part where we're talking about what is the uses of importance of chemistry in what you call it. Now we have to start with basically this. What is matter? So matter is any substance. Matter is defined as any substance, okay, which occupies space, and has mass. So at the max in your 11th standard, they may ask a one mark question, define matter. It's clear. So now what happens is, how are what do you call? Now a substance in the form of matter, what happens is now, we have how is matter classified? Okay, matter is classified into two types. Matter is classified into two types. One is a pure substance. And we have mixture. The second one is mixture. So we talk of pure substance. What happens? Pure substance, we have elements and we have compounds. When we talk of element, what is the definition of an element? See, in an element, what happens is you cannot, the smallest particle will be having the same property. And compounds are what? Element is defined as what? Is substance. Element is defined as a substance that cannot be decomposed. See, it is my firm belief that as far as definition is concerned, I will stick to the textbook. Because if you change the language, maybe the meaning of that definition will also change. It's clear. So elements are what? Substances that cannot be decomposed. Substances that cannot be decomposed by a simple chemical process. Why we are saying simple chemical process? Because smallest particle of an element is an atom. We can break the atom, but that is nuclear technology. It's not a chemical process, it will be a nuclear technology. This part here. By a simple chemical process into two or more, which cannot be, I am underlining, which cannot be decomposed by a simple chemical process into two or more different substances. two or more different substances. Okay. Then compounds. What are compounds? Compounds are defined as compounds are defined as substances of definite composition. Compounds are defined as substances of definite composition. So if you say it is carbon dioxide, it has a definite composition. One molecule contains one atom of carbon and two atoms of oxygen. It has a definite composition. Is this clear? Which can be decomposed. Okay, into two or more substances by a simple chemical process. Here. Then what do we come to? We come to mixtures. So what are mixtures? There are basically two types. One is a homogeneous mixture. And the other is a heterogeneous mixture. The other is a heterogeneous mixture. Homogeneous mixture and heterogeneous mixture. Is there? So how will you define homogeneous mixture? A mixture of simple combination of two, it's a mixture basically. Okay, what is a mixture? That also is a definition available. The mixture is a simple combination of two or more substances but what is the important point over here? Unlike, they are not entering into a chemical reaction. They retain their identity. So it is a simple combination of mixture of two or more substances in which constituent substances retain their separate identity. Retain their separate identity. So that is the definition of a, what do you call, mixture. Okay. Homogeneous mixture, what can we say? So homogeneous constituents remain. So mixture in which constituent remains. So mixture in which the concentration of constituents remain uniform throughout. Okay, and very important point, all constituents are are in the same phase. Are in the same phase. That is very important. For example, what could be the example? Ethyl alcohol and water. Ethyl alcohol and water. Ethyl alcohol and water. Then what do we have? We have a heterogeneous system. If two or more phases, one, this could be some message coming from. Hello. Hello. नहीं मेरे को नहीं चाहिए मेरे मीटिंग में वो डिस्टर्ब now listen so if two or more therefore now let me see if two or more phases are present if two or more phases are present okay in a mixture then it's called as heterogeneous mixture. Just take down this much, then I can start with the further part. Okay. When you are finished, don't put a message because there is no one to see. You say it so that I can hear it in my speaker.
Okay.
Yeah. It is big. But I'd always keep my neck like this, you know. The distance between the screen is, about nearly 6-7 feet. Nah? Finished, Shweta? Okay, chalo. Now we come to the next part, that is units. So now we are coming to units. See, what is the historical, what do you call, genesis behind this units is that initially it was land, when people were, were cave people, then hunters, and then they settled down, then they had land, and when they had land, what did they decide that they will, what do you call, cultivate. So each one then became possessive, this much is my land. So what was the amount of land that each one had to be measured? Okay, so there has to be some units to measure it. So in the olden days, what did they do? Whatever was the size of the feet of the king, that the multiplication of that became the amount that you gave. The king died, his son came, the values changed. Therefore, what happened was, for everything they had to fix. So 1961, 1961, we had 1960, sorry. I am born 1961, 1 year before I was born. 1960, that is 63 years back. What happened? All the scientists from the world assembled in France and they introduced what we call as System International. So before that, okay, before we go into what are the different types of units, we'll first define unit. So what is the definition of unit? It is arbitrarily derived. It is arbitrarily. It is arbitrarily. It is arbitrarily, what do you call, decided. It is arbitrarily decided and universally accepted standards. Universally accepted standards are called as units. Are called as units. Basically, there are two types. What are they? One is called as fundamental units. One is called as fundamental units, and other is called as derived units. Okay. So what are fundamental units? These are fundamental units which we are System International, SI unit, they have fixed. And then by multiplication or division of these units, they are multiplication. Addition, it's not addition or subtraction. It's either by multiplying or dividing these fundamental units, we get what we call as derived units. Still, so what are the fundamental SI units? So SI unit means it is System International. And when was it decided? 1960. I always tell this, so I thought 1961. So 1 year before I was born. 1960, I was born 1961. This is point clear. So, what are the fundamental units? The fundamental units are, first is length. So what is the SI unit? SI unit is meter. And what is the symbol? So this is the unit. And what is the symbol? The symbol is small m. Now what is a mistake that somebody can make? They write capital M. Capital M is molar, concentration of E. So whether with whether it's small character or large character, both are important. I tell you where we get into problems. You know what happens is in the board exam, at least over here in Maharashtra, like if you don't write the units properly, they have a chance to deduct half a mark. I don't know about Tamil Nadu, but here we take a great pleasure in cutting marks, and that's correct also. Because in the 11th we are teaching this topic. Nah? So length ke baad, what do we have? The next one is mass. Mass, it is kilogram. So now how do you write kilogram symbol? It is small k and small g. Here, like for example, in electrochemistry, what is the mass of the substance deposited? Okay, the answer is expected in kilogram. Okay, this is how you write the unit. What is the mistake people can do? People can write kg like this. This is absolutely wrong. Because capital K is Kelvin. It is a unit. I'll just put up the AC for a minute. So capital K I'll just check if the streaming is going on. Give me 1 minute. Just for my own this experiment that we are doing. Yeah. So see, we have a channel called Edumate Plus. Okay. So we are trying to do some live streaming, giving out for children some ideas like, important questions discussed live and all that. We don't want to use this because this server classes are very huge actually. So we are using a proxy server. YouTube is called as proxy server. Learn all these terms. So what happens is, listen carefully. What we have over here is, so kg, that is mass, unit of SI unit of mass is kg. And how do you represent it? The symbol will be small k and small g. It will not be capital K, because moment write capital K, it is Kelvin gram ho jayega. It will become Kelvin gram. Are you understanding? Then the third one is what? Time. Fundamental unit is time. So time is in seconds. Again over here, symbol of second is S. Like for example, I told you how much time is required for the deposition of 1 kg of some substance. So your answer will be in seconds. What is the mistake which people do is, they write second as SEC. So this is where we cut marks. Second is written as just a small s, not capital S. Capital S is Siemens. It is the reciprocal of what we call ohm, the resistance. Is this point clear? So it has to be small s. Then the fourth one is what? The fourth one is temperature. So it is Kelvin. And Kelvin will have a symbol of capital K. Capital K. Then the fifth one is what? Fifth one we have is amount of substance. Amount of substance is mole and the unit is mol. The symbol will be mol. Sixth one is electric current. Electric current, the unit is ampere and the symbol is capital A. Again, students make a mistake of writing AMP. So if you write this many amperes was passed, that is the answer, AMP. For the unit they will deduct. Is clear? And this helps, this is a very fundamental thing I am teaching, because I don't know, in life, if you ever go to do a PhD or something like that, when you write thesis, these are also checked actually, I mean, these are things which you're supposed to know. And I'm telling you, sometimes even at MSc level, people don't know this because they haven't studied, they don't protocol. So as a matter of protocol, practice every time when I tell you I will be the symbol, I'll be writing you and telling you that this is a symbol, don't make this mistake. Is it clear? And the seventh one is electric current. After that we have is luminous intensity. The unit is candela. and the symbol is C. Now, this is one thing, which we never come across as chemist. You know what is luminescence? Is your TV. When you see your TV, the TV is giving out light. That is luminosity. So the intensity of the TV, the luminous intensity of the TV screen is about 180 candela. Whereas, we are using a normal whiteboard, but you must have seen these days, people use smart board. Now, you see, TV only few people are seeing in the room, but smart board has to be seen by the whole class. Suppose we have a class of 80. Here we have a class of 120 also. So the luminosity has to be more, because it is less luminous. And if you ask me, sir, why we can't use TV instead of a smart board in the school? Because its luminous intensity is less. It's 180 candela. Whereas these smart boards, what is the difference? They have nearly 700 candela luminosity. So it's more luminous, more people are able to, see the board. So that is where there's an application of this fundamental unit, luminous intensity. I'm telling you very frankly, I also did not know. One salesman of smart board taught me this. I'll be Mr. Carr. I'll be honest with you. So he'll also learn from people. He was telling me the difference between using a TV and a smart board. Like these days in YouTube, you can connect your TV and then you can continue. If the room is small, it is okay. But if the room is very big, okay, then the luminous intensity has to be more. It's about 700 to 800 candle. Okay, so this was about fundamental. I gave an example of where we are using luminous intensity. So then the next one is what we have derived units. I give you few. What are derived units? The units of all physical quantity. The units of all physical quantities, okay, can be derived from the seven fundamental units is called as derived units. Like for example, area. So area will be what? Area we know is length square. So it is SI unit is meter, so it will be meter square. Volume, I am giving you only few of them. Okay, volume will be length cube. So it will be meter cube. You can have so many like that. I think in physics they do a very massive work on this. So take down this much. I've just given you two examples. Your textbook can see quite a lot of examples. Clear? While you are writing, I just again confirm the. See, luminous intensity of light bulb. How much is it? 15 watt is 110. Okay, great. So, now what do we come? We come to prefixes. We need this. Prefixes. So when you're talking of prefixes, listen carefully. Common SI prefixes. So you have increasing and decreasing. Right? So if you say deci, the prefix, then we have a symbol, then we have the magnitude, and then we have multiply. So 1 meter is what? 100 centimeters. It's clear. So like that, if I say 1 meter is how many decimeter? So deci is the prefix. So decimeter means what? The symbol is D. It is 10 raised to minus 1 or 0.1. So if I say decimeter, that means it's 0.1 times a meter, or 1/10 of a meter is called as decimeter. 1/10 of a meter is called as decimeter. Then 100 will be called as what? So we have centi. So that is small c. 100 will be called as 10 raised to minus 2. So multiply. So if I say this much is 1 centimeter, means it's 1/100th of a meter. Is one part. You've taken the whole 1 meter, made it into 100 parts. One part of that will be 1 centimeter. Then we have millimeter. So milli is small m. It is 1,000th of. Then we have micro. Micro is given by the symbol nu. This symbol is called as nu. Okay. So what happened? This is 10 raised to minus 6. So 10 raised to minus 6 is how much? So multiplying factor is 1, 2, 3, 5, 6. Okay. Then after micro we have nano. So nano will be 10 raised to minus 9. We're going to come across this in our DA. 10 raised to minus 9 multiplied factor is 1, 7. Then after nano, we have picometer. All wavelengths are measured in picometers and nanometers. It is a small p, it is 10 raised to minus 12. Okay. And then we have femto. Femto is small f, it is 10 raised to minus 15. I'm not putting 15 zeros out here. Okay, I'll give if you want. No need. There is one more which we commonly use, angstrom. So one, it is not Armstrong. Neil Armstrong was a fellow who had, landed in moon, first man to land in moon. So somehow people say Armstrong. It is angstrom. It is 1 angstrom is, I think, 10 raised to minus 10 of a centimeter. We'll still check. Okay. That unit is also used in case of what you call this. It's not given in our textbook, but then you will find that we are using that only. In a minute. It is 10 raised to minus 10 of a meter. 1 angstrom. One angstrom is 10 raised to minus 10 of a meter. So this is also sometimes used. Huh? This is also used. Is this clear? Then we have something above it. So as we increase, this is decreasing now. So if you have 10 times more, so then we have a deca. So deca will have a symbol dA. And how much it is? 10 times. Multiplying factor will be 10. After deca, we'll have hecto. Hecto will be given by the symbol small h, and this is 10 raised to 2 multiplied by 100. Then after hecto, what we will have? We'll have kilo. This is something small k. Remember I told you? So it's 1000 times. Multiplying factor is 10 raised to 3 multiplied by 1000. Then after kilo, what do we have? We have something called as MYRIA. How much is it? It is MY is the symbol. It is 10 raised to 4. That means 1000 is 10,000 times. Okay. Then we have mega. This is in computer, say megapixel, a capital M. It is 10 raised to 6 megabytes. So many megabytes, so many gigabytes. Now you have what you call as giga. This is, capital G. It is 10 raised to 9. Gigabyte means 10 raised to 9 times. So we used to have probably those days pen drive used to be those, it will be so much megabytes. Now we have terabytes, Tera. Terabyte is capital T, it is 10 raised to 12. Storage space. So this is prefix, then this is symbol, and this will be magnitude. Chalo, take multiplying factors also. Okay, great. Now we come to what? See, we come to real substance. This is called introduction. Now what happened was, see, we previously, what kind of people did we have? The kind of people that we had were called as, what do you call, they were not called chemists, but they were alchemists. Alchemist means what? They were just trying to mix abracadabra something, trying to form gold. This was their idea. They were trying to, what do you call, get gold. Now what happened was, the real, what do you call, change in from alchemist to chemistry, the systematic study of chemicals came about when, remember the name, but I think it's Faraday. He had developed the laboratory balance. This changed the whole. You had balance, big ones, for weighing grains, this, that, and all. The change in chemistry came about. Laboratory balance. Why? Because the laboratory balance gave the chemist the leverage of, even at that time, I'm talking 1850 and all, yeah, to weigh substance up to 1 microgram. 1 microgram. So this was an advantage. The accuracy had increased with the laboratory balance. Now our normal vegetable vendor maximum 10 grams released, he can weigh. It's clear, but this was 1 microgram. So when this happened, what happened was that scientists started looking what is the effect on the mass of reactant, on the mass of product after the chemical reaction, and in what proportion are they combining. Is the proportion whole number or is it? क्या है? Give me a minute, Shweta. मेरे को भी याद नहीं है मैंने. हाँ हाँ. I don't think right. नहीं, केमिस्ट्री से दैट एल्यूमिनियम एंड कॉपर कंडक्ट करता है, और एल्यूमिनियम का क्या रहेगा, कॉपर इज अ बेटर कंडक्टर तो नहीं, बट उसकी वजह से शॉर्ट सर्किट होएगा. शॉर्ट सर्किट कभी होगा विद पॉजिटिव और नेगेटिव से कभी क्या चलेगा, तो उससे नहीं है, डोंट स्पेंड. हाँ, नो 26 देयर इज अ फंक्शन में क्या काम था, सुबह शाम को, सुबह जेंडर है, शाम को नहीं. पक्का है, पक्का है. हाँ, सुबह है. आई कम फॉर द ब्लैक बॉक्स. हाँ, आई कम. थोड़ा ही 15-20 दिन तो कभी जनवरी में ना, 12th का बच्चे लोग अभी एग्जाम के लिए जाएगा जनवरी में, फरवरी पूरा में फ्री. देखते देखते. अच्छा, I'm sorry, this is the secretary. So listen, so what I was telling you was, now the laboratory balance changed the situation. How did it change the situation? It changed the situation that we could now understand that I have put so much of reactant, how much of product I will get, is there some loss and all that. So what happened, while this study was there, there was no basis, scientific basis to this law. They came about proposing this laws based on purely experimental factors. So the first was law of conservation of mass. So the first was law of conservation. It is law of conservation of mass. So when you're talking of law of conservation of mass, okay, what are we talking about? We are saying, now this was proposed by a German French scientist, sorry, Russian scientist. It was Lomonosov. When did he do it? 1760. So what did he say? Total mass of the reactant. He said total mass of reactant and product remains the same. Remains the same in any chemical reaction. Another way of saying this is what? Another way of saying this is that in a chemical reaction, mass is conserved. That means mass is neither created nor destroyed. That some books have said like that also. There is no problem with it. It's clear. So we can take that also as a definition. So what happened? How was this proved? This was proved by a French scientist, Antoine Lavoisier. What he did was, he took a H-shaped glass. So he took a H-shaped glass tube. In one arm, he put silver nitrate. And in the other arm, he put NaC. Weighed the arm after it was sealed. Why was this reaction chosen? Because when they react, they form what? Silver chloride. Visibly, you know the chemical reaction has taken place. So what was the reaction if you see? We know the reaction now. AgNO3 plus NaCl forms AgCl plus NaNO3. So you have to know how the chemical reaction is over. Now how will you come to know that the chemical reaction is over? You will know because dense white precipitate is formed. So what did he do? He shook it. When he shook it, what happened? Precipitate was formed, chemical reaction over. Then he again weighed. He realized that the mass did not change. There was some small mass loss, but then he realized that is because of the energy evolved. What is happening is the heat is causing the evaporation of the surface water molecules on the H-shaped tube. But overall, he realized that after repeating, mass does not change. And this is the proof of what? That mass is conserved. Mass is conserved. Okay. So what I'll do is, we'll stop here today. Sunday I'm taking the lecture. Okay, now New Year is over. Now Sunday we will complete very important Gay-Lussac's law of combining volumes and all is there. That we need for 12th standard. Okay, atomic mass and all that. So Sunday lecture is important. Don't miss this time. 6 o'clock I'm sending you the link much before 6 o'clock. So take down this much. Okay.